In problem 7, our goal is to simplify some radical expressions. When radicals appear in a variety of terms, like in part A, we can't directly combine the terms when the radicands are different. We can only combine terms of like radicals. But sometimes, as in this problem, we can simplify the radical expressions to create like radicals. 48 is 16 times 3, so we can take the square root of 16 to get 4 square roots of 3. Similarly, 75 is 25 times 3, so this becomes 5 times the square root of 3. And 27 is 9 times the square root of 3. So the square root of 27 equals 3 square roots of 3. That 3 can multiply with the 2 that's already in front to create 6 square roots of 3. And now, because the radicals are exactly the same, square root of 3 each time, I can combine the terms as if they're like terms. So I have 4 plus 5 square roots of 3, which is 9, and then minus 6. So altogether, we have 3 square roots of 3. 9 minus 6. Now, in problem B, we have two binomials that involve radical expressions. So we can multiply these out with the technique of foiling. I want to multiply the 3 with the 5, and the 3 with the 4 times square root of 2. I want to also multiply the square root of 2 times 5, and square root of 2 times 4 square roots of 2. So let's do that. Let me give myself some room off to the side here. 3 times 5 is 15. 3 times 4 is 12 square roots of 2. Square root of 2 times 5 is 5 square roots of 2. And the square root of 2 times 4 square roots of 2 becomes minus 8, because the square root of 2 times itself equals 2. So again, we can gather together the like radicals, the square root of 2 and the square root of 2, and I can subtract the 15 and the 8. So we end up with 7 minus 7 square roots of 2 as our final answer. Part C, in some ways, is a simpler task. I just need to multiply negative square root of 5 times the two terms inside the parenthesis. Everything is inside a square root, so I end up with negative square root of 15. I can multiply the 5 and the 3 together since they're both under a square root, and plus the square root of 50. The minus sign here cancels with the subtraction to create a plus. Of course, some of you might notice the square root of 50 can be simplified. So we get a simpler expression, negative square root of 15 plus 5 square roots of 2. Part D is asking us to square this binomial, which involves a radical. And so to do that, let me write the binomial next to itself, and we can FOIL, like we did in part B up above. I get 7 times 7 is 49. 7 times the square root of 7, I can't combine those, I just get negative 7 square roots of 7. And then again, we have negative square root of 7 times 7, and the square root of 7 times itself. Negative square root of 7 times negative square root of 7 is positive 7. So similar to what we did in part B, I can gather together the numbers, the regular numbers. 49 and 7 becomes 56, minus 14 square roots of 7. One more problem to go. This one's a little bit different. In part E, we're asked to simplify a variable expression. The number 75 we can simplify in the way that we've been doing. 75, as it was up here, is 25 times 3. So I can take the square root of the perfect square and get 5, and there'll be a square root of 3 left behind. But with the variable terms, I need to think carefully about what these exponents represent. X to the 5th power means x times itself 5 times. So I can take an even number of those x's, I can take 4 of them, and essentially the square root of that part is just x squared. Because if I square x squared, I get those 4 x's. So when I have the exponent of a variable under a square root, I can simplify it by taking the largest even amount and dividing it in half. And then if the exponent is odd, there'll be one of that variable left behind under the square root. So in a similar way, y to the 8th power just becomes y to the 4th power outside of the square root, because y to the 8th is y times itself 8 times. And so in a sense, I guess to write this a little more carefully, I could write this as y to the 4th squared. We would multiply those exponents to get y to the 8th. I'm taking the square root of that square, and I get y to the 4th. So let me gather together. My final answer for part E is 5x squared y to the 4th, and then under the square root, I just have 3x. So the answers we found for the part 7 questions are 3 square roots of 3. For part A, 7 minus 7 square roots of 2, negative square root of 15 plus 5 square roots of 2, 56 minus 14 square roots of 7, and 5x squared y to the 4th times the square root of 3x.